Hello, friends. Welcome to the Georgia Tech AI podcast. My guest today is Jeremiah Coholich, a Robotics PhD student in the Robotics Perception and Learning Lab. Jeremiah's journey is a fascinating one, with experiences ranging from the Mars Perseverance rover at NASA to co-founding his own electric race car team. Now, Jeremiah is tackling one of the fundamental hurdles in modern robotics, the data bottleneck. His research explores how we can make systems more robust by augmenting limited data, enabling robots to adapt to real world shifts. With a background in mechanical engineering, Jeremiah brings a unique, hands on approach to the field of robot learning. And now, dear friends, please welcome Jeremiah Coholich. So, Jeremiah, one of the first things that anyone would see when they open your website is you VR teleoperating a Franca robot for pick and place operations. Could you briefly describe to me what that project entailed?
Yeah. So I guess imitation learning has become quite a big thing for robotics in the past like 1 to 2 years. And so I set up this like platform with a Franca arm and a MetaQuest, which is like the VR headset from Meta, to teleoperate it and collect demonstrations. Yeah. So I guess the idea is like we use the built-in hand tracking from the MetaQuest to like obtain the pose of the user's hands, and then we stream that to the PC, and then a bunch of math happens, and then that gets sent to the Franca arm in terms of like end effector position, and then like we can record those actions and use them to like train a neural network to like learn from.
What was the experience like using this?
Yeah, using the VR headset. At first, it was like really, really cool when I got it working. Like, you're wearing this VR thing and you're moving your hand around and the robot is like matching your movements. You feel like very powerful. But like eventually you have to like collect demonstrations for your project and you end up doing some like very simple task 100 times wearing this VR headset. So it does get annoying. Like it like being in VR for a long time can be like, I don't know, like disorienting, or you kind of get like a headache. So actually, like the video on my website, Justin is my master's student who helped me with this. Justin and I are like wearing the headset the entire time. But we've actually learned from other like researchers doing VR teleoperation, you could just like have the headset around your neck. And then all the sensors will still see your hand and work. And then that's like much less fatiguing. Yeah.
Where are we currently in terms of the user experience? Where do you feel are the biggest bottlenecks? How can we improve the user experience for people using VR headsets?
One thing that is like a huge negative is when the VR headset lags. So like this is an, well, I guess it's an AR headset, right? So it's augmented reality. So it has all these cameras on it. When you put it on, you can see the outside world. So a lot of people will like, when you're wearing this thing, a lot of people will walk up to you like, "Whoa, like what's he doing? He can't see me." But like they're not aware that you can like see everything. Like it's just being streamed into the headset. But like if you move your head and it lags, like you move your head and the world doesn't move, that's like very disorienting. And so like often when that happens, I have to like take it off for a second. Yeah, the other thing is like the resolution. I heard like the limiting factor for VR headset resolution is actually the size of the LEDs. So it's just because this like screen is so close to your eyes, the size of the LED matters, and like just the technology doesn't exist to make LEDs small enough to get like the crispness of like a 4K TV that's like 15 feet away from you.
Also, did you get any haptic feedback when you touched the object?
No. So that is a big area of research, like dexterous teleoperation with haptic feedback. And I do think that's like very important for like doing robot tasks. Like, and like we take this for granted. Like whenever you manipulate anything, like you open a Coke can, you're definitely like, you're feeling for the edge of that like tab with your thumb, blah, blah, blah. Yeah, that's a big area of research, but unfortunately we don't have any haptic feedback. We did switch to using the MetaQuest controller instead of the hand tracking because that's like more reliable and the hand tracking is noisy. But yeah, no haptic feedback.
Understood. Could you talk to me about this area of learning from demonstration and collecting robot trajectories? What I keep hearing is there's a big data bottleneck. We don't have enough robot data to train a solid policy. Where are we currently, and what are the big barriers that we need to cross in order to scale robot learning?
Yeah, that's a good question. So right now, I feel like a lot of robotics is trying to copy the success that we've seen with large language models and large vision language models, like ChatGPT 4.0. Like this is a good example that a lot of non-technical people will be familiar with. But the issue is like those huge foundation models were trained on like a ton of data that was scraped from the web, and that data just like exists already and can just be mined. But not everyone has a robot. Like very few people have a robot, and the people that like operate the robot, they don't just like go like upload it to the web. So we don't have much less robot data, and most of it has to be collected manually by humans. So I mean, there are a lot of approaches to that. Companies like Google or like a lot of startups, like Tesla, they will literally just like hire contractors to teleoperate the robot like 24/7 and just like try to like brute force data collection that way. uh, Obviously that's like not super scalable, even if you have like all the money of Google or like other companies. So a big area of research right now is like how can we learn robot behaviors from like human video data, or how can we use like simulation instead of like human effort to learn robot behaviors, or how can we like take the like limited robot data we have from teleoperation and like augment it in different ways to make it like more useful. So yeah, it's definitely a big bottleneck right now. I do think that it will get solved eventually, probably within the next 5 to 10 years, just as like more and more companies become interested in this line of work and just like collect more and more data over the next 5 years. And then of course compute is always getting like faster and cheaper, and I'm sure people will find ways to like leverage that, whether it be like learning from videos or simulation or something.
There's a gap, the simulation to reality gap that a lot of robots suffer from, where you train a robot arm to do a simple pick and place operation, but you change anything. You change the lighting, you change the size of the block, and maybe it doesn't work. It's not robust to that distribution shift. Could you, for the audience, explain this issue of distribution shift and also how robot data augmentation could be a potential solution?
I think like distribution shift is just like a general term for like your training data is different from like the data that you are evaluating on, or in the case of robotics, like the environment that your training data came from is different from the environment that you want to. Right. So very common issue in machine learning in general or deep learning. It happens in unexpected ways in robotics. So, like one example that I've remembered, like I went to a conference, Coral, in 2023, and that was like the time when the like robot transformer works had just come out from DeepMind. And I remember one of the authors, he was saying like, that was a case where they like hired like lots of contractors over many months to teleoperate the robot to do a bunch of different things and then trained on that data. He said like all of the tables at Google were the same height, and they had collected all of their data, like manipulating objects on those tables. And then they tested it on another table that was of a different height, and it just completely failed. So, they spent months and I'm sure like hundreds of thousands of dollars, like millions of dollars probably collecting data, and it failed just because the table was the wrong height. We see that in many ways in our own policies. So like one thing that my current paper is on is camera viewpoint shift. So like a lot of like labs, they just kind of like fix the camera in place, collect a bunch of demos, with robot observations coming from the fixed camera, train a policy and deploy it. If someone like bumps or moves the camera, the policy performance like craters. Like it can go to zero from like just being shifted like a foot or something. But obviously like undesirable. It really makes you question like is this intelligence if like you just like move a camera and it just right, it just fails so badly. But yeah, so distribution shifts come in many forms. yeah, we're trying to make policies more robust. And the easiest way to make them more robust is just to collect more diverse data.
So your goal is to produce more papers on this area, robot data augmentation, scaling robot learning. I want to understand from you, what's your vision for the remainder of your PhD and also the work you'd like to do in this field? Because your paper directly addressed the viewpoint issue, right? Changing camera angles. You could even change task instructions. What are the kinds of applications that you see in your work?
So I guess, yeah, I do plan to do my PhD dissertation on data augmentation. Think like, I guess like my vision is just like I can, after my PhD, I can go to industry, hopefully join one of these companies that is developing like, general purpose robots and use like the work from my PhD to help them scale up data collection in a way that is useful. To help them collect like robot data collection requires like resources, right? You don't just scrape it from the web. So like help them use resources to collect data that will improve the policy the most, performance per dollar, and just like help them leverage compute to also increase the usefulness of the data that they've collected manually.
Very cool. Is performance per dollar a thing? Is it possible to quantify it?
No, I haven't really heard it discussed much, but I feel like that, yeah, I think that's very hard to quantify. I think like it's very hard to quantify the performance of these vision language action models in general, just because, and this is a problem in like all of robotics and it has been for a while. It's just like evaluations are not reproducible between labs or companies. And the processes are usually somewhat opaque. You, you don't know how much rigor someone is putting into their evaluation process, right? Or like what exactly they are counting as a success or a failure, or like what tasks they left out, et cetera, et cetera.
So, looking back on your PhD journey, you've taken on a very interesting path. Correct me if I'm wrong, but you graduated with a degree in mechanical engineering. You worked on exoskeletons, then you moved into quadruped locomotion, and now you're focused on data augmentation and VLAs. So, looking back, how do you view these detours? Would you say they were detours or would you say they were stepping stones?
Yeah, I would. It was definitely a journey. I wouldn't say they were detours. I feel like every step kind of just led me to where I am now. But yeah, so I started, I guess, what was the first thing you said? I was working on
MechE?
yeah, MechE. Yeah. So I was really interested in mechanical design in undergrad, and I thought that I was going to go into the aerospace industry after because, I would get to do mechanical design for like very cool things like planes and rockets or spacecraft. So I did an internship at NASA JPL actually, and it was super cool. The project was the Mars Perseverance rover. So it doesn't get more cool than that. And I was working under the engineer who was responsible for the percussive mechanism in the drill for the rover. So one of the big goals of the Mars Perseverance rover is to go to Mars, core for rock samples, right? So it obtains like core samples of rock and then packages them and leaves them on the surface. The coring drill is a rotary percussive drill, so it has like a drill and then there's like a hammer beating on the back of it. So like I was working with the engineer responsible for that hammer mechanism. So I was just a mechanical design intern, but there was another guy on the team who was like the controls engineer for that, and he like wrote all the algorithms that controlled like the drill and the percussion mechanism. And he wrote this like adaptive coring mechanism or algorithm that enabled like faster coring with like lower energy consumption and stuff. So I thought that like work was really cool, and I basically came out of that internship saying I want to go to grad school and study controls. So like the last 2 years of my undergrad, I was like involved in undergrad research with like a lab doing controls in exoskeletons. And then once I got to grad school, I kind of switched more to trajectory optimization, and then I got caught up in the RL craze, and then I switched to RL, and now I ended up in this a data augmentation topic, mostly because I got frustrated with RL, to be honest. Like tuning rewards and getting RL to work from scratch is very challenging, actually.
Let's take a step back and talk about the NASA JPL experience. I'm sure it must have been so inspiring that you worked on a drill that literally collects samples from Mars. What was that journey like? You were probably a junior working around some really smart people. Could you paint a picture for me for what that looked like?
Yeah, yeah, sure. So, yeah, I did this. It was a co-op actually. It was like a 7-month internship basically that like occurred in the summer and fall after my sophomore year of college. And yeah, basically I moved to Pasadena, went to JPL. The first day was like amazing because they take you on a tour of the campus and show you like the clean room where the actual rover is being built, so you can see it being assembled. They show you the Mars yard, which is like this. It's basically this like test area that is supposed to like mimic Mars, and they have like a full like working double of the Curiosity rover there. So I would always walk by there. And like, if I was lucky, some engineers were like taking the Curiosity rover double out and like doing some tests with it. And I mean, it was like an exact double. Like, if something goes wrong with the rover on Mars, they try to replicate and debug the problem on the double here on Earth. Yeah, so that was really cool to see. And then honestly, after like the day to day was mostly just like mechanical design with like really smart people. Just working in CAD software, making drawings, trying to get stuff manufactured, testing things. But I guess that the crazy thing is like when it comes to space, like all the designs have these like really like crazy requirements because of like issues that you would never think of. Like for example, like thermal gradients are like a huge thing. So like in space, like you can have like if you have like a satellite in space and there's no air in space, so there's no like convection, and one side of the satellite is facing the sun and the other side of the satellite is not. The side that is facing the sun can be like hundreds of degrees hotter than the side that is not facing the sun. So like the thermal expansion can cause the thing to crack. So that's like something you would like never think of if you've just dealt with stuff on Earth.
I'm truly curious about, the inspiration that got you into robotics research in the first place. Would you say that your experiences at JPL and SpaceX had a formative role to play?
Yeah, definitely. I mean, so JPL is like they build robots for space. So like that was the first time I like kind of operated robot hardware like at a low level, like using Ubuntu and like sending command line arguments to like run motors and stuff like that. And so yeah, I really enjoyed that like testing process. SpaceX was not as much robotics. Actually, when I was interning at SpaceX, I already knew I was coming to grad school for a PhD in robotics. I was just so excited by robotics. I just thought it was like such a quickly growing field. And there were so many applications, like so many opportunities for entrepreneurship, just like a lot of cool research happening. And there was a lot more like math and programming that I could learn, I think, studying robotics, which was like one of my big motivations for going to grad school, just like intellectual curiosity.
You mentioned that there are also a lot of opportunities for entrepreneurship. And I noticed that your freshman year, your first year as an undergrad, you founded a startup that was dealing with electric race cars. You managed a 50-person team, secured a lot of funding. What are some lessons that you've learned from that time as a freshman that's with you today?
Yeah, yeah. So I kind of co-founded this Formula SAE team. So Formula SAE is like a big international competition, like a student engineering competition where students build like a single seater race car from scratch, basically, which is very hard. And so, yeah, it was a lot of work. I spent like almost all my time my first 2 years doing that before I went to NASA. Yeah. So one of the biggest, so I was team captain my sophomore year. And I think one of the biggest lessons I took away from that is like, a lot of engineering projects are more about project and time management rather than like making some super fancy like design, you know what I mean? So like implementation is everything. Like once you have something that works, you can like move on to the more fancy stuff. But I also think that's a good lesson for PhD because you can come up with tons of ideas of stuff to do or like new research ideas to test. But if you can't like implement them and make them work like in a timely fashion, it's not really useful, especially in today's like fast-paced publishing environment. Yeah.
I remember we had this conversation and you said the key quality of a bad researcher is you're always in your own head. You never actually implement anything. So let's flip that. What are some qualities of great researchers that you've seen? over your time interacting with students, professors, researchers?
A very important question too. I think one like very simple thing like right off the bat is just work ethic. Like you have to be consistent, you have to put in some hours. And then the other thing that I think makes a very good researcher is like having collaborations. So like when you collaborate with other people, like you get more ideas, you can solve problems faster. And then I think an underrated aspect of collaborations is there are more stakeholders in your project, so more people care about if the project succeeds or fails, which can help move things along because like I guess it puts more pressure on you to execute, and then also because you'd be letting other people down, and then like other people will just help you because they have an interest in making it succeed, help you with their time or their resources or their expertise. It all makes a big difference.
It's very tempting to just be a solo warrior doing your own projects. Why how have you ensured that collaboration is a key part of your journey? You've also organized reading groups and you do stuff outside of school as well. Could you talk more about how you make sure collaboration is a key part of the journey?
Yeah, I think yeah. So I guess this desire has really stemmed from trying to do research during the pandemic where there was very little collaboration and it was hard for people to meet each other. So yeah, I was here doing my PhD during the pandemic, and that was quite an unproductive time for me. And I've realized that yes, I do need collaborators to be productive. I think. I mean, I can be productive by myself, but collaboration is much better. So how do I try to do this? So yeah, I guess in several ways. So like one of the ways is just by like finding other master's students or PhD students to work on projects with. And now that's easier because you can just go like walk to someone's desk and talk to them. Our lab also recruits a lot of master's students. And then you mentioned the reading group. So I did start a like VLA/embodied AI reading group, which has been a lot of fun. So it's been kind of like an open invite. So like every week we pick a paper and then we just like go over it in like an informal setting and discuss it and ask each other questions. And I think that's good because like people can meet each other. Like sometimes as PhD students, we kind of just go to our desks and like head down and like do what we need to do for the day and then like leave. So like the reading group forces people to talk to each other. It forces people to read papers, which I think is good because it's there are so many papers coming out like all the time. You do need to make an effort to keep up on some level. And as a PhD student, it's really easy to stop reading papers. Like if you have a project, you're already going for deadline. You just kind of deprioritize that. Reading papers takes a lot of time. Well, it can take a lot of time. Um, it's fun.
This is something I'm curious about as well. You're someone who's extremely hands-on. You like the implementation. How do you balance that with reading papers? How do we make sure that you've struck a healthy balance between learning about the state of the art, but also doing your own experiments?
Yeah, true, true. I think definitely reading, if you just read papers all the time, that can be bad. Because I have seen like PhD students, just starting out research, and then all they do is like read papers and they don't like run any experiments or run any code. And it's like easy to think yourself into this hole where like there are no gaps in the literature. There's like nothing worth doing. Like everyone has already done everything. So I do think you need to strike some balance there, and I think like the way to do that is just to like alternate between like reading, thinking, and then programming/running experiments. So I think that's a good cycle, and you can't let any one thing kind of dominate. um
I see. It's definitely super customized to one person, right? It's also their situation, what they need the most.
Yeah, yeah, exactly. And like at different stages in a project, you're going to do different things. Like obviously close to a deadline, you're not going to be like reading papers unrelated to your project, most likely. But like, when you're first starting a project or you're brainstorming, you may read a lot.
You mentioned starting your PhD about the same time as the pandemic, and there was definitely some isolation involved. And I want to ask you how you prioritized your mental health then and even now.
Yeah, good question. Yeah, so that was it was not a fun time, to be a grad student. I guess like the way I coped with that is just through my hobbies. So I have a good community like through rock climbing. Yeah, I got really into rock climbing after I came here. So I started just going indoors to the Stone Summit gyms. Well, now it's like Central Rock Gym. Eventually, I started going outdoors a lot, which was a lot of fun. So yeah, there's a lot of like rock climbing within a 2 hour radius of Atlanta, like in Alabama, Tennessee, North Georgia. So, like, getting outside and doing that was like a good way to deal with being a grad student in the pandemic. And then I also have a bunch of other hobbies, like pretty much all fitness related, like running, yoga, hiking, surfing recently.
I remember you told me that it's really important to do these activities because, say that research is not going well, I can just leave the office and go for a run.
Yeah, yeah. Yeah, I totally agree because like if the only thing in your life is work or research and that thing is not going well, it can feel very very bad and overwhelming. So it's good to have something in your life that is working when research is not working, and I think like for me like fitness is like something that is always good. Like I never regret going for a workout or going for a run. I always feel better afterwards.
Speaking of ups and downs, we talked about the topic changes, how you didn't want to work on reinforcement learning and you moved more to the data augmentation side of things. As a result, there was also an advisor change. And, for people going through that journey, you feel like you're starting from scratch in some ways. For the people listening who are going through a similar situation where they find that there's another topic that interests them more, what advice would you give them for navigating this journey?
Ooh, yeah. So changing advisors is definitely tough. I feel like, yeah, so people know that I've changed advisors before and some of them come to me for advice when changing advisors, and it's never like a pretty thing. It's like they're always very stressed out. It's always very, like painful to try to find a new advisor and change research topics. So, what advice would I give them? I would say number one is like you have even like when you're changing advisors, still you have to focus or stay on your research grind, like keep making progress on the project you are on. And then the second thing is just like don't lose hope. Like you can find a new advisor. Things will be fine. Like maybe you'll be in the PhD for an extra year, but if a PhD is truly what you want, then it'll be worth it. And then the other thing, which may be a more controversial piece of advice, is maybe also apply to jobs because you can often get a job and be really satisfied. And, I've seen people who just, decide to get a master's and leave, and often they are glad that they did.
You were at a similar crossroads in 2019. How did you decide that academia was the right path for you versus industry? Because you had several exciting internships and you could have easily gone into industry. How did you choose to balance that?
Yeah, that's a good question. I definitely knew that I was going to go to grad school just because of like me wanting to further my education, like intellectual curiosity. I wanted to learn more math. I felt like, with entry level mechanical engineering work, I wasn't using like a lot of the math that I learned in school, which was disappointing to me. I knew I wanted to go to grad school, but I wasn't sure if I wanted to do PhD or master's. And I debated a lot with my roommate at the time, who was going through a similar decision, the same decision actually. And it really just came down to like, it's easier to apply for PhDs. And if I don't like it, to leave rather than apply for masters and then try to get into a PhD later. I don't know in hindsight if that was like the best decision making. I think I could have probably benefited from a master's before starting my PhD, but it's working out now. So,
Definitely. And you've shown tremendous amounts of tenacity over these 5, 6 years. There have been ups and downs, but you've stayed strong. And, you're almost at the end of the journey now, and the results speak for themselves. I want to talk about the interdisciplinary nature of robotics research and how important it is for people to come in with a range of backgrounds, not just computer science. How do you feel that your diverse experiences have helped you in your robotics research today? How have they enabled you versus being seen as a distraction?
Yeah. So I will give the caveat that I do think like the major like bottleneck in robotics research right now is intelligence. It's not like the design of robot. Like we can design arbitrarily complex robots, but like the barrier is like getting them to do intelligent things, which is why there is so much research in like robotics and AI. I think like my background in like mechanical design has just helped me like implement things faster. So I'm very familiar with how to like build things or set things up. Like if we need, a new like camera mount or a new I don't know, a new setup for like a new task, it's very easy for me to like figure out how to do that. And then just like the low level stuff like debugging the robot, the controls, the stuff like that is just a little more it's less opaque for me. um
Yeah, the implementation aspect again. I remember you told me that your first paper was about 3D printing materials and you almost enjoyed building the 3D printer more than working on the research project.
Yeah. So I guess that was like something that also got me into robotics. Like my freshman year of undergrad, I discovered the makerspace, and I was like so thrilled by the makerspace. I was like, let me pick out like a really cool project. So I went online, and there's this website called instructables.com. I don't know if it still exists, but anyways, there was like a project that someone had put up for like how to build a 3D printer, like using only materials that I, could source from the makerspace. So I built this 3D printer, and I was like, wow, that was really fun. That was really cool. I want to go do like 3D printing research. So I found a professor at UT. Like UT is big into additive manufacturing. So I found a professor to do summer research with, and it was a productive summer doing research. But I kind of realized like the research in additive manufacturing had more to do with material science than like the mechatronics of a 3D printer. So yeah, so then after that stint with research, I decided to like focus on robotics research, and that was definitely the right choice.
Now, this question is more geared towards undergrads. And for them, as they see robots doing a lot of cool things on YouTube and they want to get into robotics research as well, what advice would you give them to prepare for this journey and make the most of it?
Yeah. So I would say if you're an undergrad, like at Georgia Tech or like, a university that's doing research, I think that the best thing to do is just like reach out to labs, reach out to grad students and try to get involved with the project, because nothing beats like direct experience, like training robot policies, like, excuse me, implementing them on hardware. So that's the best thing. In terms of like coursework and learning, I think it's like if you really want to do research, I think it's good to focus on like math actually. So, if you can take like linear algebra, optimization, statistics, I think those are all like really useful like fundamental topics for robot learning. You can also take like like they have a class like robot dynamics or something like that. That's also very useful. Yeah, but like math definitely, especially as like learning progresses and we kind of abstract more away from the low level details of the robot. Just like statistics and math for learning will be very useful.
In terms of the next 5 years, what do you think is going to be the most exciting breakthrough that will happen with robots in the household or in industry? I don't want to put you on the spot with predictions, but what is the likeliest breakthrough?
Hard to say. A lot of companies are developing like general purpose household robots, and I do think that within the next 5 years they will work quite well. Like you will be able to have a robot that you can give a language command to, like fold the laundry or load the dishwasher, and the robot will be able to do it with a reasonable success rate, maybe like 95%, or 90, not 100, but like enough to be useful for like non critical tasks. I think one of the issues though is just like the cost of these robots. So I'm not sure like who the target customer is, because like right now these robots cost like $10,000, $20,000. I mean, maybe I'm wrong. Maybe there's something cheaper, but I feel like that is still too expensive for like most people to just buy. I don't know. There is the stretch robot actually from Hello Robot. Their whole thesis was like we want to be the Roomba of mobile manipulation. So I'm not sure how much those cost, but maybe there are cheaper solutions out there. So yeah, I guess my prediction is just like robots in the home to help with household chores within the next 5 years.
Awesome. What excites you most about this remainder of your PhD? What are you most looking forward to as you end this journey?
Okay, so definitely graduating. That'll be exciting. I think also like traveling to conferences, that's always like a huge plus. In terms of like the research work itself, I think like I really enjoy just like running experiments and like collecting data, training policies, like making some change or like innovation, and then trying it on the robot and like seeing what kind of behavior it produces. I think that's really fun. And then I'm just like trying to enjoy my last year in like a collegiate environment, like at Tech. Um, like try to leverage all the things the university has to offer. You know, stay on campus and meet people and collaborate with people. I think that's honestly what I'm looking forward to the most, just like working with other people on cool projects.
Jeremiah, it's been a pleasure. I wish you the very best for this remainder of your journey, but also for life outside of tech. I'm sure you'll do great things.
Thanks, Kauser. Thanks. Yeah, it's been fun.